Hey everyone, geophysicist Stefan Burns. There is right now a global geomagnetic storm that's occurring. It's at a G2 level, which is fairly strong. The scale rating goes from 1 to 5. We actually hit a G2 plus storm, which means that there is plasma currently encircling our planet to a much greater degree than normal because we've had a strengthening of the solar wind being emitted from the sun. A coronal mass ejection caused this strengthening, has hit the Earth, has slowly ramped up, and now is generating a bunch of plasma, the fourth state of matter, very highly vibrational. This triggers swings in the magnetic field strength, strong electric currents pulsing across the Earth, a variety of geophysical changes, and effects that we feel in our day-to-day, whether you know it or not. This can affect technological systems, satellite communication, GPS, and more, though typically those effects are greatly amplified with like a G4 or even a G5 extreme geomagnetic storm, which this is not. But it is a little unexpected in its strength because this coronal mass ejection that hit us seems to have actually launched from the far side of the sun, which is the other side of the sun. So it was a low confidence and low probability forecast. In fact, now we're in G2 conditions, and we even had a HB30 spike to 8, which would be a G4. That's just a 30-minute period. So we had a really strong shock wave hit us. And there's a variety of interesting things happening. The most important of that and most notable is the fact that right now we are coming off of a full moon. And so the moon is in the position behind the Earth. So you have sun, Earth, moon. It's behind the Earth in Earth's magnetic field, and actually the magnetotail, which contains some of the most vibrational plasma in the magnetosphere. It's able to interact with that, and we see across time that we have stronger geomagnetic disturbances when the moon is in that full moon position or very close to it in its phasing. And it's now moving off of that exact 100% illumination towards now it's a waning gibbous moon. But we have that active right now, but there are some unusual things kind of occurring, and all of this is occurring on the lead up to some critical planetary geometry that we have really go into effect June 21st, though of course there's a lead up to that as things click into place. And that continues all the way through the end of June. So some interesting things occurring right now as it relates to the position of the planets in the solar system and these solar storms that the sun is launching. It's been launching a ton of these coronal mass ejections out into space, though they haven't really been Earth directed. This one's a little bit unusual, kind of a surprise. It was forecasted, but again, low confidence. It did hit us, a bit of surprise in terms of the strength of it, but not a surprise once you consider the full moon effect. But this is also, the perfect opportunity, these sort of geomagnetic storms, to do other geophysical experiments, you could say. If you are looking to do any sort of widespread experimentation on the geophysical system, you can kind of cover your tracks if it's during a geomagnetic storm because there's already these disturbances at play. Not saying that's the case, but it's an interesting thing to think about. So in this video, we're going to go over exactly what's happening. We're going to look at the magnetic field disturbances, the solar wind, what's happening with the sun, what we can expect going forward for the next few days, also the next couple weeks with this critical planetary geometry. And then we are going to perform a cosmic connection meditation at the end because of recent world events. There has been, a renewed surge of just war, devastation, and things of that nature. And so it's our job collectively to equalize and harmonize these energies and to promote peace and love and all the things that we're here on this planet to live for, not necessarily for destruction and war. So we are going to do that together. Right off the bat, I just do want to say thanks to a couple super thanks that have come in. First one is from James, and this is, he's a big supporter of the channel, so thank you so much, James. Your herbal coffee is incredible. Keep up the good work. I just had a cup. This is from my website, wildfreeorganic.com. It's herb coffee, and it's 50% single origin organic Peruvian coffee, but also then chicory root, organic roasted dandelion root, and then also lion's mane mushroom, and quite a bit of lion's mane mushroom, 1/8 of it. So this is what he's referencing, herb coffee. You can go to wildfreeorganic.com to pick some up. I've been drinking it a lot, of course, because I have it. We've been mixing up a whole bunch of new batches leading up to Cosmic Summit, where I will be. This is Greensboro for the solstice. So if you want to meet me, you go to Cosmic Summit, get a ticket. But this stuff is awesome. James loves it. Thank you so much, James, for the super thanks and for the shout out on the herb coffee. Great to drink during these sort of geomagnetic disturbances, because normal coffee will spike your cortisol a bit, and these sort of storms also do that. So the herb coffee, only being 50% caffeine, allows you to drink your coffee and to enjoy it and not get too overstimulated during these sort of energetic pulses. Then we also have a super thanks here from Jane, so thank you so much. She says, thank you, Stefan, for educating us and keeping us informed on all things space weather and planetary geometry. It is fascinating. Well, thank you for the super thanks. Let us get right into our magnetic field fluctuations that are occurring right now. We are back to G2 conditions. We kind of cool off from a 6.33 kp index, and then looks like we're coming right back because the solar wind is still very, very strong. So here we have these magnetic field fluctuations across the globe for about the past 3 hours or so. This is a model that takes all the different data from these ground-based magnetic observatories, feeds it in, and then plots the changes. We see our scale here. This is nanotesla, and Earth's magnetic field, for reference, is about 23,000 to 67,000 nanotesla in scale. The weakest part is right there, the South Atlantic anomaly. And you have the highest field strength in the polar regions. That's also where this plasma from the solar wind and the sun and the solar storms, everything funnels down in the northern hemisphere and in the southern hemisphere. This is the auroral ring. You have the aurora borealis up here. You have the aurora australis down there. Or, I mean, it's all about perspective. But we have had some significant aurora from this solar storm impact. There were some sightings of aurora down in New York. And there's a lot of light pollution in some of these areas. So the aurora definitely went deeper than the original forecast was like kind of maybe we have a G1. Well, it's been a G2 plus. So these are the magnetic field swings. You see that we were clearly up in like the high red there, which is 400 nanotesla or greater. You see it kind of goes through these variations, but in general, during quiet conditions, all of this, the colors will be just in this zone there, because you typically don't have magnetic field swings greater than 50 or 100 nanotesla on a day-by-day basis if you're not in a storm. But right now we are. So this is quite significant because the magnetic field interacts with us in a variety of ways biologically. Basically, every single electric field is influenced by the magnetic field and vice versa. And our heart, which generates the strongest magnetic field of our body, has a very strong connection to Earth's magnetic field. So we see these cardiac effects often, especially sensitive people or those that have cardiovascular problems with geomagnetic storms. So that's something to be very mindful of. It's really important to go outside, make sure you're grounding at this moment in time to equalize those energies, get rid of that charge. You're actually bringing greater coherence to yourself, the Earth, and the universe. Because if you have a kind of undifferentiated energy information field within you, it's kind of chaotic. By grounding, you release some of that chaotic energy that doesn't serve you, and therefore you're kind of causing this differentiation and this ordering of the energy, which is good for everybody. We have a super thanks come in from Rob. Thank you so much, Rob. That's awesome. I appreciate that. So these are the magnetic field swings that are occurring. You'll also notice that the center portion is actually quite lit up right here. I'm not sure why this is, yeah, let's do this. So the center portion is quite lit up. Normally you don't have the magnetic field swings get this high in the mid-latitude and equatorial regions, but right now they're getting quite up there. So, I mean, it's not like we've never seen this before, but definitely this is a significant geomagnetic storm. And I'm mentioning that for those that are more bioelectrically sensitive, which would be people often that have like a chronic disease or, maybe their health and wellness isn't exactly where it needs to be, just sensitive individuals. And then also for people that are electric, like just in general have an electric sensitivity, you could say. So, but this is also important as it relates to satellites and communication and radio frequency communication and a lot more. So this is one of these things that no one's really expecting there to be too much of a disturbance, and then space weather being quite dynamic and very hard to predict and forecast all of a sudden it comes in and can give a lot of these different industries a shock. It can throw off GPS navigation for farmers, like precision agriculture. That's a really big theme over the past few years because a lot more people are using that in their farming techniques. Then also just in terms of communication across different radio frequencies and airplanes and anyone that relies on GPS for navigation, this can be affected by that. So this is more significant than a lot of people realize. It can also cause sometimes outages across various apps or websites, and even sometimes like power grids can fail, especially those that are sensitive power grids like Puerto Rico, Cuba. Even though they're in like these more mid-latitude zones, if they're already really fragile, they can kind of have problems with even like a G2 storm. We've seen that before. So these are the magnetic field fluctuations, and we can look at our real-time solar wind. We're going to go back to another index for the magnetic field so we can see what's been happening, because we had that HB30 pulse up to 8, which is pretty wild. But here we have our solar wind for the past 3 days, and you see that it's been a slow ramp up like this. So it hasn't been a traditional coronal mass ejection impact. And you know, I'm not even sure that's what this is because, you know, something wrapping around the far side of the sun, I'm like, maybe. But this, you can see it's a very slow ramp up to conditions about 3 times stronger than normal, because normal field strength is about 5. We see that right there. We're looking at the interplanetary magnetic field strength up here. Total field strength, the black line. This red line is a special vector component of that total field strength, which incorporates all 3 dimensions. So this is a Z component, so that vertical component. And when it goes negative, that connects really nicely to Earth's northward positive field. And so we see that this slowly ramped up in total field strength up to about triple, which is 15, even right there going to 18 nanotesla with this pulse right there. But you see really why we've had this storm is because the southward field has gone really negative. So it's had this really nice connection to Earth's field, and then therefore this plasma from the solar wind easily enters into Earth's magnetic field, creating this plasma storm, and this creates a bunch of downstream geophysical effects. So we see it's been a long duration southward component here, and what's interesting is that you'll see this G2 plus right there. That's the storm, 6.33 for the KP index. It goes from 0 to 9. 0 is ultra quiet conditions. Once you get to 4, you're like in active. 5 is you're in a G1 storm. If you get to a 9, you're in an extreme storm. It does not go beyond 9. The KP index does not go beyond 9. So last G5 storm was way back. That was like May, like a real G5 storm was back in May 2024. But we see that we actually just got our latest print here, another G2, 3 hours of G2 storming right there. So, but it is interesting that this one, this G2 plus came in so strong right here, right around midnight universal time, and then those first 3 hours. We see our plasma density hasn't really been exceptional. Right here is our plasma density. It's been hovering around like 10 or so. So it's, you know, fairly enhanced, not low density, but it hasn't had a big spike to 50 or anything like that. And our velocity hasn't been remarkable either. We see it's all been about 400, a little bit of a spike right there from, let's say, 434 to about 500 kilometers per second. But again, nothing super abnormal as it relates to density, velocity, or temperature, but we see quite a lot of elevated geomagnetic volatility because of these solar wind conditions which have just been ramping up gradually. And you'll notice that we're still in it. We're still at 13 for the total strength, which is 2.5 times greater than normal, and negative 12 for the southward component, which is quite strong. So we don't know when this storm is going to end. That's effectively the deal right now. We just got a super thanks in from Margarita, a big supporter of the channel. Thank you so much, Margarita. You are a big shining star in the universe. Well, thank you so much. I appreciate that. We all appreciate your support. We're here to understand what is happening with the Earth energetically today, tomorrow, in the future, in the past. That's the whole goal of the channel. So we look at geologic events, geophysical energies like the Schumann resonances, space weather, solar activity, planetary resonances like this planetary geometry I've been mentioning, and then even cosmic forces, how that all comes together, and our own influence on the universe. We are co-creators. We can't discount ourselves. We do have an impact on these things. We bring all that together. I present videos almost daily. Please subscribe, smash that like button. All right, here is our HB30, HB60, and KP index. And the only difference between these is that the time resolution is shorter. For an HB30 index, it's 30 minutes. And then for an HB60, it's 60 minutes. And then the KP is for 3 hours. So if we go here to our 30, this is also 10 days of data right there. So we're looking all the way back to June 4th. We see that we've been kind of in on and off, like active conditions. Again, these values around 4, even 5 right there. A few of these values up to 5. Nothing really to write home about, but still like pulses of increased activity. It hasn't just been like hovering near baseline the whole time. You know, we get those conditions at times, especially during like a solar minimum. We haven't been having that. But you'll notice, check this out. Right here, this is this first one. Well, let's zoom in on this. Let's make this really easy to see. So here we have this one right there. That's from midnight to the first 30 minutes, so 12:30 a.m. On today, the 13th of June, universal time, 7.667, and then that last 30 minutes of the hour going up to 8. That's a G4. Now it's only for 30 minutes. Combined, this would probably come in at this value right there, which would be G4 minus. Maybe you come in at G4, but that's only an hour. But that shows like kind of like an interesting shock wave, right? So like definitely like a EMP pulse there, because we see that we were ramping up. We had that, but then we basically went back to this baseline there, and even a little bit dropped from that. So this sticks out. Let's measure it. These other values are all around 6, okay? And this one's slightly above it, but if we average it out with the others, this baseline right there is 6 and even below. That right there is 2 whole values above 6. So that's like some significant pulse of geomagnetic activity that we had for 60 minutes, basically. These 2 right there. We can scroll down to get our 60-minute measure, and it came in as an 8. Yeah. So we had a 60-minute or 1 hour pulse that was quite a bit stronger than everything else that we've had thus far. Let's look at our solar wind again. We're doing a little bit of detective work to try to figure out what this is, okay? If we go here, this is measured by the Discover satellite at the L1 Lagrange point. So this is 1% of the distance from the Earth to the Sun. And therefore, we get about a 1 hour heads up. It's less if this velocity of the solar wind is really high, which it is not. So let's say it's a 60-minute heads up. So the point is that what you see here is what will arrive on Earth 60 minutes later. So if we want to examine that period from midnight to 1 a.m. universal time today, the 13th, we have to go and look at everything from 11 p.m. or 2300 to 2400 UTC on the 12th, which we can do right here. So here is our solar wind right there going from 23 to midnight. And you see that it's not really any different than the conditions that we have here or even in the couple hours preceding. Now there is a bit of effect where things can, you know, as the wave comes in, it builds up and then that triggers something. But in general, we don't see any significant like extra pulse of strength in this time frame that corresponds with the HB60 bump of 2 over the overall baseline. The only reason we're not seeing that reflected here is because this is a 3-hour measure. So it's kind of average it out. That's why this is a 6.33 and not a 6, or even perhaps even lower. So this is kind of bizarre. We can look at this also with our GlowTech model. This is a measure of the ionosphere, effectively, the total electron content. And this is aggregated from a variety of GNSS receivers. And so let's give this a watch. I think it's going to have to update as new data come in. But we'll see that the overall model is basically static, and then it registers that pulse. So check this out. Watch. Here's our time. Watch right there. We start to see the storm come in, and then we see things start to kind of cool off and go normal. But all these receivers registered a strong pulse right around the beginning of the storm. Again, check that out. See that? That's like some sort of pulse. And then it kind of re-equilibrated. And we're looking at the total electron content of the ionosphere. So this is that plasma. The more plasma you have in the ionosphere, the higher the total electron content. You can see that just becomes suddenly more volatile right there, just like that. This is just the total, the normal model. Here we can look at the difference model. This is the 30-day difference. I'll just turn myself off. And we'll see that shock come in. Look at that. And look at how all of a sudden we create these anomalies. And there's a really big anomaly near Hawaii. So here, just watch this area again, right around Hawaii. We'll see that shock come in and the anomaly that gets created. Very unusual. See, that's a big TEC difference, total electron content difference for that area during that time frame. So just kind of unusual. I mean, it just, the signature of that increase in the geomagnetic volatility for that 1 hour is more indicative of something really strong all of a sudden impacting, but we don't see that in the solar wind. So it's a little bizarre. And that's why I mentioned at the beginning, like if you wanted certain things that you can kind of hide, you can do that during a geomagnetic storm because they create similar signatures. And so we've been exploring that a little bit on the channel. I'm not saying that's at all the case, but it's an interesting idea to think about. We can go to our earthquakes to see if maybe that created the pulse, because earthquakes have been associated with ionospheric disturbances and things of this nature. So, a big earthquake could do that, perhaps. We've also seen even magnetic fluctuations from really big earthquakes in Earth's total magnetic field. So it's not impossible. But if we go to our earthquakes for the past day, this is all earthquakes magnitude 2.5 and greater, and we search by largest magnitude, we don't see anything over a 5.3. So actually earthquake activity is quite low right now. I think that's probably likely to go up now that this storm has hit and it's active. We'll probably see a bump up in earthquake activity for the next few days. I would expect there to be more magnitude 6 earthquakes coming up, but that remains to be seen. Now switching over to, I believe it's this image right here, we had the full moon. So happy full moon, everybody. It is now past the main phase, the main full moon phase. It is a waning gibbous moon now, but the full moon in general lasts about 3 days. There's a center period, maybe 36 hours on each side. You look up and it's clearly a full moon. We don't have to get too analytical or precise about this. And the larger transit actually lasts about a week because the moon will move into Earth's magnetotail. Because it's orbiting around the Earth, right? So a new moon is here, where it's actually outside the magnetic field. And then it will go square, still outside the magnetic field. But then when it goes full, it's going like this, right? And then it curves in, and then it enters into the magnetic field and can start interacting with the plasma that's contained within the magnetic field. And there's a lot of very highly vibrational or relativistic particles trapped in the magnetotail, and the movement of a large solid body through that is going to disrupt that, especially when the electric field dynamics on the moon are quite wild, because you have all this light from the sun hitting the surface. This is across the entire spectrum of light. So a lot of that is a very highly vibrational ionizing light, like extreme ultraviolet X-ray light. And so that can break molecular bonds and create plasma. So you build up a very powerful electric field gradient here versus the dark side, which doesn't receive the sunlight. And so there's a really big change in the electric field. And therefore you have to think about the electric field dynamics. Less so the magnetic field, more the electric field dynamics of the moon moving through the magnetotail, because plasma is not only under the control of magnetic field, but also electric fields, because these are charged carriers. They're charged particles, so they move with the electric field. And so you get this large electric field, very highly charged electric field, basically gradient, moving through, boom, enters into the magnetic field, and this will cause plasma reorganizations. And what we see is that we have stronger geomagnetic disturbances when the moon is in that full moon position in general. Here we have data going from 1874 to 1954. And they lined up the lunar phase with the geomagnetic disturbances. Here's the number of magnetic occurrences, as they call it, with the lunar phase. So this isn't telling us the strength of the disturbance, but just showing that they're more frequent during the full moon. Here we have the new moon, phase is 0, full moon's 180 degrees. And then we have quarter moon right there. This is also the full moon. So this graphic, loops back like this over here, okay? You'll notice actually that our highest values for occasions of these geomagnetic storms is basically right at the phase that we're in right now. Maybe we're like right about here or so, because the full moon was just about 48 hours ago, if that. So it takes, a week to go from full moon to third quarter, which is what this is right there, or last quarter as they're calling it. But we're right in this zone right there, and you see that is where we have the highest amount of geomagnetic disturbances. You'll notice the strongest trend in general, disturbances are higher when the moon is in the full moon phase, quarter phase, full moon. So this would be like waxing gibbous, and this would be waning gibbous, this would be waning crescent, and then this would be waxing crescent. But the strongest signal in this definitely is that we have less geomagnetic disturbances when the moon is at the new moon position. Some people call it the black moon or dark moon at 0 degrees, directly in front of the Earth. That seems to maybe change the solar wind and blunt the effects a little bit. But definitely the moon being the magnetotail makes these sort of disturbances stronger. And so that could explain why we've had this stronger storm than maybe was expected. The G2 storm is definitely not forecasted with this coronal mass ejection. Honestly, the solar wind doesn't really show the characteristics of a coronal mass ejection, but it's definitely some sort of strengthening pulse in the solar wind. We've had a bunch of plasma explosions from around the sun. So let's look at our sun, see what's been doing, because that could, when the sun's just very active in general, that can, when the sun's just very active in general, that can just kind of supercharge the solar wind overall. But before that, we have a super thanks came in from Andrew. From what I've been tracking, this geostorm was caused by the solar energy sheet ripple hitting harder than it normally does, likely due to ongoing magnetic field weakening. Yeah, the solar wind energy ripple, you could call it, being stronger than normal. That makes sense. So thank you, Andrew, for the super thanks. I think we've had some other ones come in too. Reminder that we are doing a cosmic connection meditation at the end of this broadcast to help harmonize these energies, bring in some more peace around the planet, especially considering recent events, which are unfortunate to say the least. So yes, thank you. We will do that at the end of the video. One question here from Danny, do pets need to ground too? Yeah, I mean, everything generally benefits from grounding during these sort of energy enhancements. So yeah, I would definitely do that. And bring your pets out. Go for a walk. Go to the park and get your pets with you. If they can go, your dog, if you have a cat that's of interest, you could. Anyways, here is our sun. We're looking at the 304 angstrom view, and we're going to look at some of the plasma explosions that have been happening on the sun for the past 48 plus hours. But also, there is another solar storm coming in very, very soon as a result of a large coronal hole. We'll talk about that. But here we see these plasma eruptions really nicely. I mean, this one was pretty epic. We see a whole bunch of nonstop disturbances from this group there. It's been flaring like crazy. And so it's possible that this sunspot cluster, maybe, there's actually a couple different sunspot groups. They could perhaps work together to launch something big. I wouldn't be surprised, especially with the critical planetary geometry that we have coming up that I've mentioned and talked about, which we will discuss a little bit again in this live stream. But in general, just some big eruptions from all across the sun. Most of it like, see that one right there? Most of it plasma based. So these plasma filaments are destabilizing. And when you get enough of those launched out, you're just going to in general strengthen the solar wind. That's kind of my philosophy. It just makes sense. So that could explain why we're seeing this broader solar wind push right now, because there's just been overall a whole bunch of little shock waves from these sent out in all directions, and they've been kind of amplifying and combining together to create this enhanced solar wind that's headed our way. So because the plasma density is, fairly high at about 10 particles per cubic centimeter, it's not super, super low. We can also look at our, well, here is our 211 angstrom view of the sun, which just shows us this very large coronal hole. And this is the next big space weather factor that we have coming up that we know of. It's very, very obvious. This is the 10th rotation of this. So it's been active for a while. That's back going all the way to October of 2024. It takes about 1 month for it to rotate around. And a coronal hole is a part of the outer atmosphere of the sun, the corona, that is very low in plasma density because it's been kind of vacuumed away to other areas, and therefore temperature, because with less of those particles, the temperature is going to be lower there. So it shows up dark in this wavelength of light, but it's not a hole that goes through the sun. It's nothing like that. It's just in this wavelength of light, it shows up dark. It doesn't show up as well in other wavelengths of light that we use to analyze the sun. But the interesting dynamic is one of the reasons the plasma density is low is because the magnetic field here is emanating out and not looping back into the sun like we see these coronal loops, right? All these areas, we have the magnetic field of the sun looping back in. So it's kind of more of a closed system. This is an open magnetic field, so it streams right out. When that hits the Earth, it in general triggers greater geomagnetic volatility. Though it depends on the characteristics of the magnetic field, and this is a positive polarity coronal hole. So we have a forecast out by NOAA for a G2 storm around, actually going into effect, they say probably tomorrow, the 14th, but we'll probably get maybe even a few pulses of that. We have this section there cutting through the equator, which means it'll be geoeffective. This is the geoeffective position right here due to how the solar wind kind of spirals out. It's not a straight line like this. It kind of spirals out. So when it's in this zone there, that's when it connects to Earth very nicely. And we also, in general, want these coronal holes to cross the equator for them to have a good connection to the Earth. If they're really far to the south or to the north, they won't do so. And also, in general, the bigger the coronal hole, the more significant the effect could be. Again, that polarity matters. So we see this portion right there going basically right to the equator. This portion has been strengthening. I actually expect when this goes geoeffective right there, I expect that to be a bit stronger than just this little bit right there. But we'll just have to wait and see. But in general, this is the biggest thing that we have coming up. I'll pause it right there. And you see that it's continuing to stretch down because this has been a big coronal hole now for a while. Rotation 7, 8, and 9 have all been large. Rotation 10 is slightly smaller, it looks like, but still very, very large. Long-lived, causes continuous energy loading on the longer time scale into the Earth because of those high-speed stream impacts, and there is some research connecting that to significant earthquake activity on the globe. The mechanisms that would cause that are still being kind of figured out, though there's quite a lot of good ideas that aren't too complicated, and in general, simpler ideas are better. But it's probably it's almost certainly multifactorial. And of course, there's all the other variables that are happening at the same time. So it's hard to pin down precisely, but we do see a signal rise above the noise in general as it relates to coronal holes and earthquake activity. So when this goes geoeffective around the 14th, 15th, 16th, that zone, we may have higher magnitude earthquakes and more of them during that time frame. Something to be aware of is if you live in an earthquake prone region. And volcanoes, I would say, probably fall into that as well, though their dynamics are a little different, but both seem to be plasma-based to some degree. So when you have a plasma storm on the sun, well, and on the Earth, well, we kind of resonate with that, you could say. We've also just had a large coronal mass ejection launch from the far side of the sun, because I haven't seen any imagery for this on the Earth-facing side. But give this a watch. You'll see also some of the other ejections that have occurred just in the past 24 hours. This is our wide view. So this is 32 solar radii across, but check out the speed on that one. That's from that sunspot group. It's kind of a combined sunspot group that's rotating into view. We'll check that out soon. But check out the very end. Let me actually pause it on our latest one here. See this? Coming off slowly, but there it is right there. So that is a pretty significant coronal mass ejection, not launched towards us, but showing that the sun is continuing to be very, very active. It's been active, it's continuing to be active. So in general, this is just kind of keeping things spicy, you could say. And let's watch our other coronagraph here so you can get a sense of what I'm talking about. There's that most recent one there. So pretty slow launch, probably from a plasma filament, but we don't know. I think that's from the far side because there's nothing on the Earth-facing side that indicates that that was launching from Earth-facing. And I have some other data here. Let's just see what it is. That's our perturbation map. And we have our real-time solar wind. Let's look at our sunspots really quick so you can see this cluster that I'm talking about. It's nothing super crazy, but we have more sunspots on the sun than we've had for a while. It looks like some new groups have popped up too. We have a super thanks from Sherry. She's donated many times before. Thank you so much, Sherry, for the super thanks. And thank you everyone in the live stream here supporting the channel. It's awesome. I really appreciate that. Together, we've done amazing things already, and we're going to continue to do so. So that is great. This is these multiple sunspot groups that are soon to be rotating Earth direct right here. And we have these ones rotating out, and I believe this is a new cluster that's just popped up. So I've been talking about how we were going to have an increase in solar activity and solar flux being pushed out of the sun for the past few days now. In fact, I've been forecasting June 21st out for, that'll be like a 5+ week forecast for space weather. And it's not June 21st yet. We'll have to wait and see what happens around that time, and then also till the end of June because of the planetary geometry. But I have been forecasting that there will be greater solar activity around that zone, and it seems that we're ramping up to that because we're ready right now in this G2 storm from perhaps, we don't even really know the source of this strong solar wind, but it doesn't have the classic CME signature. It's just like a gradual ramp up. So I think that's kind of the dynamic at play. We're going to continue to have strong activity like this going all the way through the end of June through solstice, which typically is when you don't have the strongest activity. During solstice, you don't have the best connection to the solar wind. Doesn't mean you can't have storms though, but it's just one factor kind of working against that. Whereas the full moon, for example, as we showed, is like one factor working towards more geomagnetic disturbances. Let's look at our sunspot number to see what that is. And we should be, we're right around 150 still, as you can see. So we have been on a 30-day uptrend now, but we reached a really low spot there with 50. This is solar maximum. To go down to 50 sunspots and stay there is like, okay, we're in the descending part now. But then it's been ramping back up. So the sunspot count for May was only 79, according to NOAA, which was a massive drop. And if we go to that really quick, actually, let's talk about that just for a moment to give a longer term perspective as to what's going to occur, very likely. Because just what we see in nature and reality, if you pay attention, and this is reflected across a variety of things, not just solar cycles or maybe geophysics and stuff, is that when you get a big drop or a big increase in general, there's going to be greater volatility. So here we see this very significant sunspot drop, also reflected in the solar flux down here, though it did it over the course of a couple months. It was almost a leading indicator versus this is literally in 1 month. We dropped nearly 50% from our average, which you don't really see in any solar cycles going back. I mean, kind of, but this is notable across all the solar cycles in this record here. When you have these sort of big swings, you often have a rebound in the other direction, whatever that is, up or down. And so we're already seeing sunspot numbers now getting back to 150, which is this line right there. You see that right there, 150. So we're not going to have a sunspot count of 150 for June because some of those low values are stuck in the beginning of June. But it's likely we're going to see a rebound out of that. This is August right there, 215 for our monthly count. It's unlikely that we go higher than 215 for the rest of this solar cycle, though it's possible. I mean, it is possible. There are solar cycles where the second peak was stronger, but we see one right at the beginning here, though it's quite rare. But we see, here's one peak, and there's like kind of, you could say, a second peak that's a little bit later, but there's a better example somewhere in the record. There's a lot of solar cycles to look through. I'm not sure exactly what the number was. But some of the, usually you get one peak and then you kind of descend down from that. But sometimes there are records. Here, for example, we have a whole bunch of peaks. So we kind of oscillated very heavily between high and low. Here's a double peak structure. And I think that second one is just barely lower than the first one. But I remember seeing a solar cycle in here where the second peak was definitely the strongest. And this actually right here is a solar cycle at the beginning of the 20th century that is similar to the drop in volatility that we just had. If you see this right here, look at the big swings up and down, but they never breached 200 for the sunspot count. But there's interesting things like that that can happen. Here's a good example. We had this ramp up, and then actually we had a stronger increase for sunspots there, whereas we had a big drop right there, right? We had a huge drop, and then we actually went higher. So we do get these sort of dynamics at times, though it's not the most common. I can't find that one solar cycle that I found. Maybe it's at the very beginning. Or maybe shown in one of the other data sets. Either way, maybe it was this guy actually. It might have been this one. Let's see the count. That's 298, and this one's 300. So about the same actually. But showing that you can have a high count, go down, and bounce back up. That's the point of that. So look at the longer term trend. Solar cycle 25 maximum, very likely going to start really entering that descending phase middle of 2026, I would say. But you get a lot of activity during the descending phase as well. So it's likely that we're going to have these sort of solar storm impacts going all the way through 2027, 2028, and then we'll start to finally hit that solar minimum around 2029, 2030, 2031, 2032. Things will be quiet. We'll have more galactic cosmic rays coming in at that time. I also want to point out, we've talked about this before. I don't know what is up with my my web browser. I can't click anything that's to the right for some reason. But I can click it now. I just had to close out some tabs. Here we have our Starlink constellation. And they're pumping up these Starlinks into orbit all the time. When you have geomagnetic disturbances, it can cause these sort of satellite failures because they encounter more drag. Because during a solar storm impact, the upper atmosphere actually will raise up in vibration and then go up to a higher altitude, therefore increasing the density of the upper atmosphere. So the exosphere becomes more dense. That increases drag on satellites. In general, there'll be more reentries. There can also be like what's known as deep dielectric charging of satellites, which can cause like a short circuit and therefore a malfunction that can cause a problem. So Starlink has more than 8,000 satellites now in space, and the overall number of satellites is something like 12 to 15,000 or so. So the majority of satellites now in space are Starlinks, by the way. And so I just want to show you this graphic here, okay? We're in a storm right now, which could indicate that, over the next couple of days, there may be an increase in these re-entries and these failures. And we've seen this time and time again with geomagnetic storms. Here we see the total number of Starlinks. We see how it's been accelerating since basically the beginning of 2025. And we see the ones that are active or in service with the green line. Then we have inactive ones in yellow, then burned up ones in red. But let's turn off the service ones. Let's turn off the total ones actually, and then also turn off the inactive ones. Look at how the re-entries has been going up exponentially. And actually this is probably the beginning of this exponential curve, because they want Starlink to be 40,000 satellites plus. China wants their own mega constellation or multiple. The EU and a variety of other governments and companies, big companies, are working on this. So Starlink's just first mover, but look at how they've been increasing dramatically. If we go to the end here, look at this. We'll go mid-December. We had 628 that were burned up, and it's already gone up to nearly double that number, 1,121 as of the 11th of June. So a massive increase just in 6 months. We've put on nearly the entire amount of burned up Starlinks for this entire time frame, going back to 2020, sometime in 2020, going back to August of 2020. Now, just in about 6 months actually, because this is mid-December that we're measuring from. Just in 6 months, just under a near doubling of these Starlinks that have burned up into our atmosphere, depositing metallic particles all across the atmosphere, burning up ozone, creating metallic oxide dust, very likely strengthening these geomagnetic storms because of the conductive ions that are created. Some of it lingers there. So just wanted to bring awareness to that. We've been talking about that. This is one of the main, maybe not the main forces, but one of the big forces right now of Earth electrification that is continuing because of the increase of electromagnetic emissions like radio frequency, which would be, for example, power grid noise, 50, 60 hertz, but other frequencies around there too. You also have all the AM and FM radio frequencies. You have first responder and like hospital and government frequency use, which is a huge swath of the radio frequency spectrum. You have all the cellular communication. So you have 2G, 3G, 4G, 5G, and you also have factors like this. So it's really quite significant, not to be ignored. That's why earthing and grounding is so valuable in the modern day and age. And I do want to talk about our planetary geometry. So let's check that out. We have a space weather model here from the UK Met Office. We have this, what they showed, this solar storm there. That's, past. That may be what's causing this increase. There was something identified and modeled, but again, as I mentioned, the characteristics are kind of unusual. So just don't really know. And, I did state a couple of videos back, like if you're a sensitive person to this, then you should take precautions, but it's a low confidence forecast. So, I did mention these things, but it definitely a G2 plus storm is maybe not exactly what I was expecting. So, doing my best to stay on top of this for you all. Here we have this coronal mass ejection that they just modeled that launched off, because we've had a bunch of activity. This was from yesterday, this launched off. So notice the direction. Here is the Earth, there's the sun. This is top down looking on the ecliptic plane. Again, this is the Earth, that's the sun. So it's going there to the right, you could say. This is solar coordinate system, that would be the west. So we're going to the right there. Not interacting with the Earth, but let's check out our solar system scope, which is our model of the solar system. And here we have that, and this is set for today. This will be sufficient to show what I'm interested in showing. And we can see the Earth right here. We see the sun, okay? Well, what's off at that 90-degree angle? Oh, it's our planetary geometry I've been talking about, and all the other coronal mass ejections that have been launching for like the past 3-4 days have been launching towards Mars. So we've been having solar storms launch out along the sides like this, and that plasma is going to energize these planetary bodies. And look, it's June 13th right now. So this has been happening for the past few days. So, beginning of June. Well, this critical planetary geometry I've been mentioning doesn't click in till the 21st. Here on the 21st, we see that Mars, Mercury, and the Sun are all in a line. So from Mars perspective, this would be a Mercury inferior conjunction, or just Sun and Mars conjunct, or Sun and Mercury conjunct. And we see that the Earth is basically 90 degrees to that, while it is on the other side of the sun from Jupiter. So this is a Sun-Jupiter conjunction on this date. And actually, that goes exact on the 25th. On the 25th or so, 24th, 25th, if you look up at the sun during the day, you're also basically looking at Jupiter, because it's going to be on the other side of the sun in alignment with it. But that's the 21st. So we have that guy right there. This is pretty notable geometry. Mercury is said to be an activator of this. And there's quite a bit of research showing these planetary geometric configurations lead to or are connected with solar activity, space weather, and geomagnetic disturbances, and just geophysical disturbances as well on the Earth. That could be volcanoes and earthquakes. And then we go forward, let's go to the 30th or so, and we go back to our alignment there. Look now, we have Mars, Mercury, Venus, Ceres, Saturn, and Neptune all in a line. And on June 30th, around that time, that will be enough time for that coronal mass ejection we just looked at in the model to have reached Saturn, perhaps even Neptune. Because that's, what, like 2 weeks? That's 2 weeks out? More than 2 weeks out. So it would take maybe 3-4 days to reach Earth at 1 AU. So it's going to start being in that zone around then. Or at least there's going to be more plasma here than normal. So there's going to be a strengthening of the electric field and the magnetic field at that time. So there's going to be a stronger energy connection electromagnetically between all these bodies around that time because of all the coronal mass ejections that have been launched out. Then of course you have the heightened gravitational vector at that time, and they're all slightly ahead of the sun. So this perhaps could create disturbances on the Earth-facing side. Jupiter there in the back could also be in general contributing to this through its geometry, this grand cross geometry. We also have Uranus and Pluto, in a trine configuration with Mercury and Mars. Pluto's right there. So they're in a trine configuration. There's also a kite configuration. Pluto 60 degrees to Neptune and Saturn, 60 degrees to Uranus, which are then in this 120-degree trine to Mars and Mercury. But then the Earth right there is like on the other end of that dish. That's Earth facing, and all these disturbances I've been talking about are going to be right on that Earth facing side. It'll be really interesting to see what happens around that time frame. Nothing could happen, but based on some of these space weather forecasting methods, which utilize planetary geometry, this is a time period that we can expect to a greater degree or a greater probability there to be significant disturbances. So we'll just have to wait and see. But right now, so far, this is a new method for me. I've only been using it for a few months. So far, the track record, though, is 3 for 3 for the dates given. And some of those dates given were well in advance, too, like 6 weeks. So we'll just have to wait and see. But that is one of the energies that we're building up to. So this full moon has come in and kind of activated that. Because again, remember also the moon is reflecting a lot of light, and not just visible light, but it's also reflecting ultraviolet light. And we have extreme ultraviolet light production from the sun up right now because of solar maximum. Also, X-ray light is increased right now as a result of solar maximum. And we can look at the signature of the moon, in fact. We have a graphic for that. So let me pull that up so you can get a sense of, the moon is more important than a lot of people realize. I think a lot of people discount what the moon is doing. So we see the moon reflecting light across different parts of the light spectrum. So this is radio frequencies right here. It actually reflects the Milky Way radio signature because of its high albedo. It's like a mirror, effectively. But we also see ultraviolet reflections of light from the moon. We see visible light reflections. That's what we see. We see infrared reflections. That's more like thermal heat. But even gamma rays, it's one of the brightest gamma ray objects in our sky because it's reflecting all these gamma rays from these celestial sources. So really significant. And when you take all that into context, there being a full moon adds an extra dimension to any sort of energy disruptions that may be occurring on the planet. Because plasma is also charged. You create plasma with these high frequency emissions like ultraviolet, extreme ultraviolet, X-ray, and gamma ray. So if you have a big mirror adding, reflecting this light right back down onto the ionosphere, which is getting supercharged at this moment in time, you're going to expect it to be stronger. So you don't have to get into a super complicated idea or theory to explain this full moon effect. It's quite simple, actually. Quantifying it's a different story. Like what the actual quantification is difficult, but as we showed, we do have some quantification of the phase of the moon and the number of lunar disturbances, at least for this time frame, 1874 to 1954, which is a good length of time. I mean, that is 80 years? 80 years, folks. That's a very long time frame. So that's some good data, right? It's not 2 years of data, 80 years of data. It's good stuff. In general, right now, big plasma disturbances across the Earth as a result of this geomagnetic storm. So aurora sightings, northern hemisphere, southern hemisphere. Northern hemisphere is tough though because we're so close to solstice, so there's a lot of light, and also at the full moon that makes it even harder. If you're in the southern hemisphere, it makes it a little bit easier to maybe see aurora, and this storm is continuing. Let's just check one last time. We'll see what's happening see if any notable earthquakes have popped off. Since we checked it, because if something big happened, we want to be there first to talk about it. But no, nothing big has happened with earthquakes since it was discussed. And if we go to our real-time solar wind, we'll see that things are still the same as I just showed you. So yeah, we are still in a G2 storm right now at this moment in time. G1, G2, the solar wind is still remaining strong. Big energy volatility across the planet. There's some downstream effects from that lasts a couple days, even up to a couple weeks. So keep that in mind. And we have this coronal hole high-speed stream soon to connect to the Earth, keeping this volatility going, leading all the way up into this critical planetary geometry active around June 21st, going all the way through the end of the month. So We'll just have to wait and see what happens, but I think it's going to be more significant than people realize. Let us now do our cosmic connection meditation, and this is going to be fun because I found a few other instruments to play. You could say I'm traveling right now, so I did bring my Tibetan singing bowl with me, which we've been using for some of our meditations. I also have my 174 hertz tuning fork from Biofield Tuning, Eileen McCusick. She's a sorceress. This stuff is really good for helping also kind of cleanse your biofield and your aura and ground you. These are very grounding, but this is a very nice frequency. We'll play this as well. But I also have some new instruments, which I'm going to leave a surprise for you as I play them. So yeah, let us get started with our cosmic connection meditation. We're joining together in coherence and harmony to bring about peace, love, to help equalize and harmonize the energies of this planet. We have just received a strong pulse of energy from the sun and from the moon, working together, gold and silver, yang and yin, masculine and feminine, the yin and yang. We seek to bring them together to temper our strongest aggressive impulses, but also add some fire to our emotions, to live life very raw, vivid, visceral, but in harmony. So relax your breathing. Feel the vibration. Relax your face, your body, your mind. Extend your energy from yourself to the earth, to the sun, and to the cosmos. Feel what is the underlying unity. Feel your third eye. Envision the world that you want. Birds chirping. Everyone living peacefully together. An earth green with vegetation, blue with oceans, snow-capped mountains. Feel your crown. Put on your crown. Be the change that the world needs. Pray for peace. We extend our love, healing to everyone that's affected right now by conflict and war, bombing, attacks, hatred. But together we are stronger. We reject the false powers at B and recognize the true law and power of God and His chosen ones. The universe is inside each and every one of us. We are all co-creators, together in coherence and harmony. We are the true deciders and decision makers of the evolution of the earth. Thank you all so much for joining me today, for taking part in this Cosmic Connection meditation. Wishing all of you well as always. I'll keep you up to date with what is happening. So please subscribe if you'd like to see all the future updates. Wishing all of you well. I'll see you all in the next video. Ciao.